I'm Stephen Foskett, organizer of Tech Field Day, and we are here in Austin, Texas with a group of international delegates who've come in to learn and discuss and ask questions and interact during this technical presentation. You're about to hear from Uila, which is a new company to this audience, and I know that there will be a lot of discussion. If you'd like to learn more about Tech Field Day, go to techfieldday.com. You can also go to youtube.com/techfieldday to see more videos like this.
My name is Chia-Chee Kuan, co-founder CEO for Uila. And with me, I have my partner, Roger Yao. Roger, why don't you introduce yourself?
I'm Roger Yao. I'm Uila's VP Engineering. It's my first time to be here, join this Tech Field Day event. It's my pleasure. And today I'm going to be your demo guy. So hopefully we can give you some exciting, demo. Thanks.
Yeah, so Roger will be the main guy. I know slideware is not very welcome here, but unfortunately we'll have to shove it down your throat for like about 7 of them. And I'll do that part. Hopefully we'll get through that part really quickly. So first order of business, company name. So last night I was chatting with a few guys, and then everybody seems to having some problem pronouncing the name. So the name Uila pronounces Uila. It is a Hawaiian word. Uila in Hawaiian meaning is thunder, thunder in the sky. So the metaphor behind the name is such that in the thunder or in the sky, when there's cloud, it's in the metaphor of cloud computing, it's cloudy, you can't quite see anything. With Uila, thunder in the cloud, you gain visibility with lightning and everything else. So since we are about full stack, cloud computing, data center visibility, and also all the other names are taken anyway. You got to go Hawaiian names. So no, even this name, we have to buy the domain from some squatters to get the domain. So in any case, it's a story, but anyhow, we realize it's pretty difficult to pronounce until you heard it from somebody, but that's the kind of the story behind it, right? So with that, I'll just jump into our 7 or 6 slide very quickly. So we are founded 2013, so the company is relatively young. We started in Silicon Valley in Santa Clara 2013. And fortunately, we have product release on the market for about 18 months or so. So we've been out there a little bit, but really in terms of go-to-market, in terms of making ourselves known in the marketplace, it's just, I would say our effort starts here. And we're very excited to really make some investment. And finally, this is the first event that we choose to do with Tech Field Day or with any effort that we do. So this is our first choice. So we're very, very excited. So before we jump into the technologies or jump into the products, I'd like to give you a little bit background of the founders, our background, our history, what leads us to this place. So the bunch of us, the founders of the company, we've been working together for the last, say, 2 decades or so in the Valley. So we're a bunch of networking guys. In the early days, very, very early days, this is going to show my age. We were doing TCP/IP implementation for operating system that don't even come in with TCP/IP protocol stack. So you're thinking about the 80s. That's when we started working. And that is when we put, for example, writing TCP/IP protocol stack for DOS, if you still remember such a beast, IBM DOS, or some people are old enough like I am, still remember that, or even for Windows, for that matters, Windows 2.0, 3.0, they don't come in with TCP/IP. So back then, in the 80s, there are a company writing TCP/IP protocol stack for those, and we are one of those guys writing TCP protocol stack, and as it advanced a little bit, you write NFS, you write file transfer, you write email system, start building up from that protocol stack. And that's how we got started. So with that, the founders jumped into and started a company to do protocol analyzer. That's the first time we started to start company and then really dig into protocol capture, or you called it the sniffer nowadays, or back then. Sniffing packets, analyzing packets, and then from networking side of things to do troubleshooting, right? Very networking. So back then, the company was like Network General. That was a very famous one. And we started a company. So the story of that is that, software is going to be the hardware. So the market leader was using hardware to do packet capture, and we come up with software-based solution on Windows and then that type of thing. So packet capture really is a root of our expertise. And since then, believe it or not, you'll see a little bit trace of that still in this current company that we do. So that company that the founder co-started, Cinco Network, was later acquired by Network General, which, very interestingly, they combined hardware and software solutions. So you put the best software in the best hardware, and there you go. So, and then after that, we continue on our journey on packet capture, protocol analysis into Wi-Fi space. From Wi-Fi Pocket PC back then. Again, this is still old, right? If you remember, today everybody's iPhone, smartphone. Back then it was HP iPad, if you will recall, or Palm device, if you will recall. And we were, again, those guys bringing software onto those devices. Back then it was $50 per application. That's considered very, very expensive. We came up with a Wi-Fi analyzer, protocol analyzing of 802.11 packet on iPad, and we sell for $1,500, which is unheard of. It's outrageously expensive, but we got a pretty good run of the company. So then that company later got sold to Fluke Network. So, long story, too long. Anyway, that's the history of it. The reason why I'm introducing that here now is you will see we are trying to bring that packet capture spirit and packet capture and analysis technology into the virtualization. And we think that is something that really can change the way that we look at things. Packet capture, virtualization into a virtualized data center. So the journey of us coming into the virtualized data center with a packet capture background was actually going through a middle stop that was to really focus on virtual networking, which we believe virtual or software-defined networking or virtual networking going to be so new, so big. And as we dig into it, we finally realize, which again is the spirit of the company and the mission of the company, is that networking alone anywhere is not sufficient, or anything alone in the data center is not sufficient. Storage alone, monitoring, because we're on monitoring alone, is short. Application alone is short, networking alone is short. No matter you go up and down the stack, physical, virtual, you got to be all inclusive. Right? That's our revelation, and that's how we see the market gap. That is how we founded the company. So probably spent too much time on this slide. If I'm boring you, I apologize. I'll jump to the next slide. So a little bit of a commercial. So we've been on the market for about 18 months. We do have some customers in larger data center. So we collected some meaningful customer base and quite a few data center servers, mission critical application servers being monitored and managed by us. So we published, so far get permission from our customer, published about 3 customer case studies on our website. But primarily, I just want to get everybody into, what kind of sector are we getting into, but really virtualization, data center, VMware, Hyper-V, or KVM, or what have you. There really is not a very specific vertical that these are used. If you're a data center, you're running business, you got to use some of these things. So our business is no different. So we get into enterprise. For example, one use case is Lake County's emergency medical services. Obviously, mission critical, people's life depend on it. They have a data center, and the CIO use our solution. Right, very quickly from trial to really putting our solution into your data center, into his data center, is just very quickly, just a couple months. And then where they're up and running becomes very dependable solution for them to monitoring their mission critical data center. So that's one space I would put them in, healthcare, data center, and also enterprise space as well. We also have service provider. For example, GDS is another one we have permission to talk about their use case, where they are a top tier hosting company. They also do managed service provider. People here probably have not heard of them, but they do host Baidu, Alibaba in China. Those are huge data centers. They use our solution to provide the managed service and primarily to serve their tenants in their managed service. So we got customers like that, and then we're continuing to build. So kind of that's a little bit of the background of our market traction. Any questions?
I think you actually answered it. I saw AT&T listed on the service provider space there. Are you allowed to discuss the value that you're providing to them?
AT&T not yet.
Okay, well then I will not press you on this.
Yeah, thank you. Yeah, we are working with some of these. Yeah.
And I would be interested in understanding if they are using their solution. I'm not pressing you to answer this, but as you're asking them for permission,
Right.
whether it is used in their hosting side or if they're doing anything with your solution in accordance with their Domain 2.0 refresh,
Right.
as well as their 5G LTE rollout and mobile edge compute centered around cord.
Right. Once we get permission, I'll be more than happy to circle back with you.
I would love to hear it.
Thank you. Yeah, but service provider is an interesting space for us. The difference between the service provider and enterprise is that service provider, they have a very clear divide between the tenants and actually the operator. So our solution, actually you'll see later on, is very much for the operator, or in the enterprise is for the IT ops, but yet having visibility all the way up the stack to the tenant or to the application, but without intruding or having to place agent to do instrumentation at the application space or tenant's application space. So it's very applicable for service provider, operators, or enterprise customers. So you'll see that later on, but sorry, I cannot reveal too much about AT&T, but
Your customer hasn't approved it, and thank you for honoring their wishes.
yeah, thank you. All right, moving forward. So what are the challenges that we see and then hope to backfill the gap, right? So kind of at the very top level, what we've been hearing from the IT ops community is troubleshooting. Is very time consuming. Nobody really make a strong schedule or allocated a lot of time for troubleshooting, but in reality, they spend a lot of time to troubleshooting. I can't recall how many meetings I was with IT ops managers and directors, always in the middle of the meeting of the conference call. They have to break away because something went haywire, right? They have to go fix it right now. And then a lot of times, it either take a long time and getting involved with multiple group of people to solve a complicated issue, or before they can really solve the issue kind of disappeared, right? And then problem solved until 3 months later it come back again, right? So we see this repeat again and again and again, and there's really no good solution. Everybody has tools, so it's not that there's no tool, but still it remains a challenge. And then the second challenge that we see is in the now very complicated data center, the coverage in terms of monitoring to assure application services, whether it's a service availability or the service performance level, is not complete. Meaning there are always something that's not being monitored, so it goes out of performance boundary or even not available. IT manager didn't even know until the phone rings, right? So for example, application servers, sometimes you monitor the top 10 that you can place agent in, you're willing to monitor and spend the effort on. The other 9,000 or 900 or 90 of those, you don't pay attention to, you don't monitor. Or you monitor on storage, but I don't really monitor on networking. Or I monitor on networking switches, but hey, I got this V switches dropping packets like crazy, nobody's monitoring on it. In many cases, as we talk to customers, when we ask them the question, hey, you know you have V switches, they go, yeah, I know, I have V switches. But we ask them, hey, when V switch drops packet, is that the networking guy's responsibility or the VMware admin guy's responsibility? Or who would be the first one to know? That's an ambiguous gray area. So, coverage for network or for data center monitoring remains kind of spotty in our view. And lastly is when you do optimization, do planning for the data center, we see the analytics that being able to cover the entire protocol stack is still quite lacking. So kind of these are what we see, the challenges. And as I mentioned, not that the market doesn't have tools. So this is the place where your head is probably already spinning as I spend the last maybe 5-10 minutes talking about all these challenges. You're probably thinking about a lot of tools. I have that, I have this, I have that. They address this and that. But in our view, so this is the place where I may be challenged. I'll welcome your challenge to see whether our position, our view is correct or not. First of all is we do realize there are a lot of application monitoring tools. We pay a lot of attention to application. We think data center exists there for the purpose of serving applications, right, to support applications. So application is number one. And there certainly is DevOps guy. There certainly is application server owner or application owner. They have tools. They have lots of great tools in the market. Right? And then we are not targeting our solution towards the application owner or DevOps guys, but they have tools. And can we use those tools to monitor on the entire data center? Right? Is that sufficient enough? Our claim is, no, they are not. They are wonderful and great, and you have to have them, and you should have them, you being the DevOps guy. But can we leverage those tools to monitor data center? We believe not, for several reasons. One is most of them require agents embedded inside the application server. They learn very deeply into your application server. And for a larger or decent size data center, you have easily thousands of application servers. For each one to deploy applications, agents, or deploy agent into the application server is prohibitively tedious, right? Plus, the way to upgrade it, maintain it, it's very complicated. And then secondly is the agent inside the application. It knows the application tremendously well. But on the other hand, as they go down to the protocol stack, can that application server monitoring or management solution tell you, the overall application running well or not well is due to for example, a storage device having congested access. So I/O ops is so high, and down to a infrastructure level root cause. So far, we're seeing that capability is not being the focus for the application. We call them APM tool, application performance management tool. So again, we're not addressing that level of the user, but that tools, we believe, is very difficult for the IT ops who manage data center infrastructure guys to use to manage the entire data center. Okay, now going down the stack a little bit, there are tools that people use to manage virtualization. I'm sure here everybody is very familiar. There are lots of tools out there. And the way that we look at those tools, and we still see gap in the tools provided by many vendors, including the virtualization platform vendor, the VMware, the Hyper-V, the KVM, or what have you. They all have tools. And the way that we see the challenge is that the tools kind of lack the application level visibility, kind of converse to what we talk about the APM level of tools, and lack the application level visibility. And also, what we also see is the tools or the virtualization focused tools tend to lack the networking level. And we believe networking, especially moving forward in the virtualized data center, especially virtualized networking, is going to play a major role. And then for the current tool to kind of not pay enough attention to the networking side of the data center is lacking. And lastly is we see mixed environment. Not every data center is pure. Of course, there are pure VMware shop. They don't have any physical server that is legacy. They don't have any Hyper-V. They don't have any lab that runs anything else. Certainly those exist, but we see the majority of the data center today, they are still in the process, or they're still, a set, sometimes a handful of physical servers that they cannot virtualize. Even though it's just a handful, you do still want to monitoring. And especially, they cannot be virtualized because they are critically important, or they are legacy, they cannot get rid of them. So monitoring on those, even though just a handful of physical server, is critically important. And then the virtualization tool typically would not cover those, right? So that will be host again. And then going down to the physical layer, are there a physical layer tool? Probably even more. There being, storage monitoring tool, sysadmin monitoring tool, and especially the networking tools. It's an $800 million market just for the tools alone. Certainly, there's a lot of networking vendors out there, right? But the way that we see that again, we see gap in there in the way that if you are looking into networking, today's networking tools, you see them gradually go up the stack or already go up the stack from networking to application. But on the other side, virtualization still is a weak spot for most, if not all, of the networking vendors. The virtual traffic that goes between VM that does not even show up on your physical switches, many of them use Band-Aid solution to source the packet to still a very hardware-based solution to process the packet, to do monitoring on the networking side. So we see the virtualization layer being weak when you come down to the physical layer tools provider.
Do you foresee any downward pressure, I guess, from a market point of view, as the network hardware vendors continue to optimize their like unified fabrics and start becoming more application and virtualization aware? Do you think that's going to be, kind of a challenge that you'll have to push back against, or do you see that as not necessarily interrupting what you're trying to do here?
I think the trend is quite strong. I think the networking vendor are probably the early guys who push from networking stack to the application, right? So they are the first guy to be paying attention to application. Virtualization, I think many of them also realize virtualization is important. Many of them are focusing on virtual networking and then network function virtualization, domain 2.0, the gentleman was just mentioning, that definitely is something that's very important to the networking guys. One thing that is hard for the networking company, this is my personal view, is once your company is so hardware oriented, 99% of your revenue come from hardware, to transform a company into a software-based solution. Because I do believe to be really monitoring on the virtualized data center, software solution is the way to go because it's so dynamic. Virtual data center or software-defined data center, forget about software-defined, storage software-defined, networking or software-defined anything. It's so dynamic, you have to be software to be following along with it. So hardware-based solution is very difficult. And from the business model-wise, I think everybody recognize you got to be very virtualized, paying attention to virtualization. The hard thing to do is not technology. It could be business. To transform your 99% of your revenue from hardware-based into software-based, that's hard. But I think if you ask anybody, any technologists or visionary guys, whether virtualization, networking, the full stack visibility is important or not, I think you will get a very consistent answer. That is the way to go. My view.
Perfect.
Yeah, thank you. Okay, so any other vendor you want to bring up or any specific view about how we see the gap and how we see the solution in the market today is lacking in terms of providing a full stack correlative? Yes, please.
Yes. So with the emergence of new distributed sensor technologies as well as distributed actors throughout, throughout industry, and I'll use an example of systems like Siemens puts into the chemical plants they manage, or that Boeing or Rolls-Royce are using for their engines that are literally that took all of us around the world to get here today. That is, in my opinion, a giant distributed network.
Absolutely.
Outputs. I didn't hear you address that directly in this market gap inside of here, and I see it's for IT ops. Are there ways that you have been exploring or that you believe that your product set can provide value in that space?
Certainly. So that's a great point. At least so far, my talk has been very focused on the data center, right? Very so data center focused, and then inside the data center, our technology, which Roger and I will demonstrate and describe a little bit, we are kind of distributed sensor ourselves. So in the data center itself, but I guess your point was, okay, the data center may be serving a collection of sensors that's distributed out there. How are those performing? And then is that something that needs to be monitored, or how do we provide value in that environment?
And my question inside, I was just trying to make sure that I had shared the information that supported my question. My question is, one, have you explored how the products that you've developed and implemented in this wide, vast array of customers you presented to us at the beginning, have you explored or encountered instances where your intellectual property and your technology and your product has been able to add value in these kind of distributed Internet of Things world?
Yeah, thank you. Got it. So the answer, the quick answer is not yet in our practical experience with the customers. The closest thing to it is we do have large customers where they have not a lot of sensor out there, they have a lot of user out there to access the data center.
Yeah.
So in our vision, in our view, the way that we look at the 7-layer networking, from the physical layer all the way to application, we actually very focus on the application layer, plus the layer number 8. The way that I look at it, in my view, that may map to what you just mentioned is we pay a lot of attention to the end user. So some of our customers, they have large number of end user, could be by site, could be by whatever way that they collect them together. So how do we help them, not just monitoring on the application server doing well or not well, but all these people, these users out there, whether they being real human being or users or sensors, how are they doing? How is the individual group or individual one that do well or not? In the case of the networking guys, networking vendor, they call it the end user experience, which basically is you're monitoring on the server performs well, but how about that user out there? Is he suffering? And if he's suffering, is it because of his own issue, so he's only one odd bird in the forest, or is it because of networking lag between your data center to him, or is it really because of your data center server, therefore the whole cluster of your data center application topology, right, the multi-tier. So we address that. We do address that. So later on, we'll do a demo and show how we add value to that, but unfortunately, I have to answer no, because we don't yet have the experience with the sensor.
You know what? Just because you don't have the experience, that's not an unfortunate thing.
Yeah.
It's not.
Right.
If you're, what I heard you say, and correct me if I'm wrong and misinterpreting this, that from what I described to you, that you found a parallel between how your current product works in your consolidated, centralized, or distributed applications and distributed user force, and through your experience of 25 years of making stuff work over IP, that you believe, in your interpretation of my statement, was that there is a parallel between that, and that
Absolutely.
your inventions may have value, and that you're looking to explore that.
Yes, we love to.
That is nothing to apologize about,
Thank
sir.
you. Thank you. Yeah, thank you. Yeah, I mean, that's actually very interesting. I mean, in the previous company, we deployed sensor, because sorry to go back history a little bit, we deployed sensor for Wi-Fi monitoring, Wi-Fi networking. So it is really our sensor, back then, the previous company from the founders that monitor on the Wi-Fi network. And then a lot of time you collect the data that we collected back is kind of, hundreds of thousands of Wi-Fi users. You can imagine, the Wi-Fi network, how big it is today, especially from the operator. And then get to that scale, the challenge is exactly what you described.
I would suggest if you ever find insight around this, especially in context of AT&T's Domain 2.0 or
Right.
LTE, especially the IoT gateway stuff that they have inside of the core architecture that they're bringing to market.
Right.
If you ever are able to click something together, I'd be really interested in hearing about those insights.
Got it. Yeah, look forward to explore that with you.
Thank you.
Thanks. Okay. So moving onwards from here. So this is how we kind of look at the stack. So I kind of talk a little bit about the 7-layer. So you see the top layer, we're putting the end user in there. So as we monitor on the data center, not only we monitor on your data center, from your very bottom, you have your vendor, your favorite vendor, your EMC, NetApp, or whoever provides your data center's technology, right? With all these equipment, plus you have your physical machine, physical devices, virtualization, and all the application built on top of that. This is what we call the full stack. And we want to be, our claim is not only we want to go to the application layer with everything included on this slide, but also go beyond that to the end user. That's what we called the kind of the end user experience, all the way down to the technology, to the bottom, to the physical layer for the entire data center experience. So with that correlated together, and we will be able to address the challenges that I mentioned in my previous slide. That is, troubleshooting takes forever. That is, I have spotty coverage for my entire data center, so I cannot ensure any services, or when I need to do optimization or planning, I don't have the analytical data to help me do that based on facts, right? So with our kind of a full stack visibility and correlation, we believe we can deliver that value. So we will certainly demonstrate that today for you and welcome your challenge. So this slide is kind of a little bit more of the marketing slide, but I'll spare you with that. So now this slide, this will probably get your attention a little bit here. This is, okay, now, this is prepping for Roger to give you a demo. So this is probably almost the last slide, one more slide after this. How do we do it, right? I claim so much. How do we actually do this that's so different from anybody else is doing that? So this is the overall architecture. I'll explain each one of these components. We are networking guys, right? Bunch of networking heads, packet heads, doing network analysis in a virtualized data center. So the first thing that we think that makes us very unique is we try to get the packets from the virtual switch. So I apologize for the very small font and very small picture. So the circle on the left, imagine that circle being your server farm. You have a lot of racks and racks and racks of server running. For example, if it's VMware, then you run ESXi on it. And inside ESXi, you have virtual switch, right? You have hypervisor kernel, you have virtual switch. On top of virtual switch, you got 20, 30, 40 virtual machines that are talking through the virtual switch to the network or to each other within the hypervisor. So any communication you do with the virtual machine, which is your application server, go through that virtual switch. So what we do is go to that virtual switch. We attach to the virtual switch. We sniff the packet. Again, this is something that we did 25 years ago, right? Over 30 years ago, we sniff packet. We still sniff packet. And guess what? The packet that we sniff out is still IP packet, still TCP packet, right? And still application packet. What do we do with it? We analyze it to death, right? This is something that we know how to do well. IP level, utilization, TCP level, Windows 0, TCP retransmission, TCP retry, TCP, all these things, sliding window, TCP sync, three-way handshake, all that sort of thing at the networking level. Many, many, many people know very, very well. And we do that, right? That's not earth-shattering technology. Now it gets a little bit more interesting. We start to analyze into the application layer. So we understand about 4,000 application protocols. That will cover, in our customer base, almost 95% of the application that they do. Of course, if they develop something that is in-house, we don't know. But nevertheless, we cover 95%. Yes?
If I'm raising my hand, please feel free to continue a thought.
No.
And address me when you feel
Love the question.
So 95% of the data that you see passing in front of your sensors is described within your current code. You can decode it. Can you describe to me a process of what happens when you or your customers see something in that 5% that is undescribed? And can you describe to me an example of when you've found something that is undescribed and how that has made its way back into the code where it now becomes described and available to provide insight?
Right. So far, we do encounter some customers, they have their own kind of a developed code. So how we deal with that is, first is when we do understand it, the protocol, the value that we provide is A, the application response time, right, which is very important in measuring application performance. And B is the transaction. What is the query and what is the response, right? If it's a SQL query, this is a select statement, and the response from the server is table not found, right? So that is the type of information that we collect for them. But if it's a proprietary protocol, or somebody may ask me the question, what if I encrypt my packets, right? Many people do. Although in today's data center, once we get into the data center, surprisingly a majority amount of traffic is still unencrypted. But in any case, for those encrypted, or for those, as you mentioned, those are proprietary protocol that we do not understand, we continue to provide the value of being able to measure application response time. So to our value, I think that's one key value where I can use it to correlate application performance together with everything in your data center.
May I ask a follow-up question?
Sure.
Let me think of a good way of phrasing it, if you will. With the rise of open source technologies such as OpenStack, Docker, and others, in mine and many other people's experience, we've seen the protocols that connect the different components of these application stacks change sometimes every 2 weeks, but normally every 6 months. How has that affected, with this rapid change in protocols are happening for the virtual infrastructure layer you loosely described, but also this kind of application infrastructure layer that's emerging everywhere? How have you provided value in providing insights into those technologies? And are you doing anything to work with the communities or observe the communities that are creating and testing these new application descriptions? So that when a new release of OpenStack comes out, or a new release of Docker, or insert open source project XYZ, like at Fission we heard about yesterday, how is there examples, or is there a way, or how do you provide value in that kind of new world where everything's rolling new so quickly?
Yeah, great question. Thank you very much. I'm glad that you asked this question, because it really is dear to our heart in terms of understanding the application, and that is definitely no small task. Yeah. So for a small company like ourselves, how do we even keep track of that, right? So this is the secret sauce. So this, I'm going to have to reveal the secret sauce. That is important. That is changing. So, but the packet analysis to get to that level is not something that we want to reinvent the wheel. It is something that's very mature. So we use a technology, or use actually a OEM technology that we actually pay dearly for, but that actually give a lot of value here. So the way that we meet that purpose, again, the challenge is the protocols are changing, right? Changing so fast. How do you as a small startup company, Silicon Valley, 3 years old, be able to keep up with that? It's impossible. Exactly right. Then the secret sauce is it's a technology that actually there are vendors who actually, especially they specialize in doing that. And the engine that we use is very much the same engine that you use. I bet everybody here, your firewall or your, I cannot name vendor, but your firewall most likely, and I would say under 99% of the chance, is using the same engines as we do. Because if you think of security, you got to do the same thing.
What's your insertion point, right? So, network packet capture, got it. But are we, that consumes a tremendous amount of horsepower and bandwidth at times, right? So are you guys doing like passive taps? Are you relying on hard taps? Are you guys, like where are you in the process that you see the data without crippling your system? Right,
thank you. So we are very much implemented as a virtual machine. So, and also on the side, we're not inline and software. All of our solutions are software only. So we maintain the philosophy, we don't want to interrupt with your workflow. So whenever there's any CPU stress or memory stress, we give up. We go, okay, your workflow is number one, right? And then number two is, even if we crash and burn, we are a virtual machine. It doesn't interfere with your workflow. So that's the least thing we want to do. And then your challenge is a good one. What if traffic is heavy? Are we going to take CPU memory from other workflow? Are we going to make them slower? Are we going to start dropping packet ourselves? Right? So we're very cautious about that. And then we use one core VM and very small memory footprint. Memory is very, very light. And the technology that we use, they actually can go up to I think it was really high, like 10 gig of speed with very limited CPU usage. That's a licensed technology that I mentioned. And then we actually, on top of that, when we sense we are stressed, we start doing sampling. And then lastly is when we started to be forced drop packet. This is a thing that Roger is going to talk about a little bit. What we have seen is, yes, physical switch drop packets, virtual switch drop packets as well, right? And then we sit on top of virtual switch. So when virtual switch drop packet, we're at the victim of it, right? We're downstream from it. But what we do is the saving grace is that when we drop packet, we know. And not only we know we need to switch to sampling mode, we also are able to detect the virtual switch is dropping packet. You got 20 other virtual machines on this critical server. This 19 are also dropping packet, and we'll point that out for you. So I think packet drop is a reality, and TCP is done so well to recover. But when it's severe, it really does impact your performance. So we pay a lot of attention to that. Yes.
Can we,
Does that answer your question?
Yeah.
Yeah, thank you.
So as a virtualization engineer, I understand that you can capture packets, but that's beyond anything where I'm at. So when I'm deploying or having the solution, I see you have that circle on the left is hypervisor vSwitch. How are you interacting with that? Is there like an appliance on every host that you're monitoring, or is it a NetFlow type communication out? Like, what is the, I guess, architecture in my data center to get this problem solved?
Right. So architecturally, we are one virtual machine per hypervisor. So it's, again, back to the sensor analogy. If you have 1,000 hypervisor, you have 1,000 of our virtual machine, one for each hypervisor. Very distributed. That's how we can be scalable. So if we have one virtual machine to serve the entire data center, then it's not going to be scalable. So this is how we be scalable. And then we don't use NetFlow. Right now, we will use NetFlow to networking devices out there. But on the hypervisor, we go to the very detailed single packet level. That's how we can be millisecond level precision. So if your application server is 5 milliseconds slower than it used to be, I would know. Right? So that's how we do. But we are not inline, and also we are on the hypervisor. I don't know if that answered the question.
Yeah, so I guess to kind of simplify, if I have 100 hosts, ESXi hosts, that's 100 deploys of the appliance, or just one?
It's no hardware appliances.
Oh, no, it's a virtual appliance. Or?
Right, virtual appliance. Yeah, we don't use the word appliance for it because it's really small footprint. So we call it a tab, a virtual smart tab. But in the end, not to playing with marketing words, it's a virtual machine, very small footprint per hypervisor. So 100 hosts, it will be 100 of our quote unquote virtual traffic tab.
Yeah, so my Power CLI is putting a OVA or I'm doing it in the GUI 100 times. Okay.
Exactly. Okay. Exactly. Yeah. And then yes.
You'd mentioned a lot about your TCP IP experience and how you're providing insight within IP-based protocol stacks. Are you able to, or is it within the capability, are you able to currently? And if so, please describe it. And if it's not, is it in the capability of your entire stack to provide this level of insight for non-IP protocols? An example would be RDMA over Ethernet, remote direct memory access over Ethernet, where two systems can effectively share memory, emulating what used to be on InfiniBand.
You got me. You got me. We don't.
I'm not trying to get you. I'm just
no. That's we haven't. So without current protocol analysis, if it's not IP based, I don't think we do much. I mean, if it's IP encapsulated in some other protocol, that we'll be able to strip it out. For example, if you have, in virtual networking, you have VXLAN, right? It's encapsulated inside, the VXLAN header, that type of thing. It's in the end, it's still IP, but we can parse to that level. But like some physical layer, we can also parse as well. But if it's like something, other than completely no IP, then our value proposition is significantly reduced.
Okay, thank you very much.
No, I know they're still out there, and then unfortunately we don't exactly address non-IP protocol stack.
95%, still a whole lot.
Yeah.
Okay.
Yeah, thank you.
Please move on.
Thank you. Okay. So this is our kind of the one part of it. So the key thing is this particular VM that I mentioned, it process packet in there. It doesn't forward any packet out, so it doesn't create any network bandwidth utilization. It processes, so the only thing that go out of the virtual machine, we call it a virtual smart traffic tab. We call it smart because it does the processing right there and then. So what came out of it to our controller, which is another virtual appliance, is only the metadata. So the metadata includes a TCP level or networking level information statistic, plus the application level intelligence, right? Like which VM is talking to which other VM, and then what are the application protocol being used, what are the application response time, and we'll pick up the worst transaction with the records for you. So later on, when you do troubleshooting, because of this, you can look into the transaction level information, which Roger later on will demonstrate for you. And then we talk about the middle piece, which is a controller that receive the metadata for application and also networking data. But at the same time, it also go into your virtualization platform, VMware vCenter, for example, to pull out information about your virtualization. This is where we marry the two sides, right? We marry the application, the networking on the left, and then on the right, we go to your virtualization. There are CPU level information, memory level information, CPU ready, for example, memory swap time, CPU ready time, all these nitty-gritty detail counters, plus the I/O ops for your storage per physical devices, for your LAN, for your data store, and for the VM, vDisk, all this level of information, CPU usage for the cluster, for the host, for the VM. Again, we put all this information out, plus the name of the VM, and we put it out from the right-hand side, right? So now, at the infrastructure side, plus the application, we actually get all this information together in one place. So data collection is really important. This is, if you want to have, we want to have full visibility. First, we want to have full coverage of the data. The instrumentation's got to be complete. So we could collect data from this way. And also this controller also cover the physical devices. Not everything is virtualized, right? So you do certainly have physical server that may be your IBM machines, that is your database server that you can never virtualize. It's still sitting as a physical server. We then would also go into it to do query, right? And also we capture its packet from other forms or do GRE tunneling to get the packet into ourselves to do processing. That is the job that the middle piece controller is doing to provide full coverage. And then
you don't have anything that will tap a physical switch directly. You're forwarding the traffic into this appliance if you're doing physical switch monitoring.
Yes. So what we do are two ways for physical devices. One is we can go to your physical switch, your Cisco switch. We say, hey, there is port number 23 is hooked up to your physical server. That's critically important. Do a GRE tunneling of that packet and send it to my virtual traffic tab. And my tab will be processing those GRE tunnel traffic. So this is purely software-based solution. And the other solution is we will give you a Linux image. You can put it on your general purpose Linux box, and then you use spanning, physical spanning.
So I could have a physical tap.
You can have a physical tab. And then if you really want it, we can give you a physical tab, not give you, sell you. But we don't really want to be, that's more of a service, the way that we look at it. We don't want to be a hardware company, but if any, we do realize some people want to have and have to have physical solution. Then we, as a customer service at cost, we will sell you something to meet that purpose. Make sense? Okay. So then this kind of almost complete the architecture. And then lastly is we do have a cloud-based service. So it's SaaS service in our cloud that all the data goes to. We use Hadoop database, so it's big data. We have this many thousands, hundreds or not hundreds, but tens of thousands of application server that we're monitoring today. Data comes there and stored in a Hadoop database, very scalable. And we do also realize many customers, they are not able or unwilling or can't for regulation purposes not be able to go to SaaS-based services, right? We have about half and half of this type of customer. In that case, we will bring our server down on premises for you. So we deploy another virtual machine in your data center to serve this. Yes?
Your SaaS platforms, is it available in multiple countries? So is it available in the EU as well as America for those customers that have data export restrictions where they're not able to have that data come back into an American-based cloud platform?
Right. So far, we have one data center ourselves that's based in US right now. And I understand in Asia, especially in China, sometimes it's difficult to get to the US. But that's a very true issue. And so far, what we have seen, the SaaS model in Asia Pacific is somehow not quite there. So in through our limited exposure to the Asia Pacific market, we are primarily selling on-premises solution and per customer request.
And may I ask a follow-on?
Please.
The feature differentials between on-premise and SaaS, how closely are so if say I would like to run this say I'm a theoretical person who has financial data that I cannot legally export. I can't even view it. I can't even view it on a screen from either Europe, China, wherever, crossing country boundaries. Laws are complicated. And I would like to implement this solution. Is there a feature differential between the SaaS platform you have and the on-premise platform you have?
No, it's identical. I think the only question is the scalability. Because in SaaS, we use a lot of hard iron, right? We have to because we serve so many customers. With our customer today, if at least our delivery today is one VM or a collection of VM implementing Hadoop, but nevertheless, it is still virtualized solution. So far it's scaled really, really well. We're very impressed with the performance that Hadoop can provide. But I think if we go to, for example, AT&T level, if it's deployed fully, then we have to go to hard iron, the physical box level. Then we will use professional services to do that. Our packaged product today doesn't go to that level.
Do you provide the professional services to make that happen on-prem as well as your SaaS platform?
Yes, we do.
Thank you.
Yes, thanks.
This is basically going to be the obligatory question, but what happens when your cloud, we lose connectivity?
Connectivity?
Yeah, I don't have a link now, and I'm trying to, still collect my data. I'm looking at this and assuming perhaps that the virtual information controller and your virtual taps would still be collecting all of the relevant information, and then once you figure out who unplugged the cord and talk up to the cloud again, it would mass upload, or it would. Is that fair? That's what would happen.
Yeah, that's very fair. That's very fair. So we, as you probably noticed, right, we leverage some of the technology that's available out there. So this one, unfortunately, we didn't pay for it, but we're legal to use it. There is a technology. So we use Hadoop, right? That's something that's public domain, and that's great. Along with it, to your point, to maintain the data consistency when the connection is not there, there's a technology out there called Flume. So some of you may understand or have used it before. Flume, basically, it's a pipe technology that they would allow you to, for example, in our case, we're communicating from here to there or from here to there. So everywhere when you have pipe, what Flume provides for you is buffering up. In case the connection is broken, it will automatically buffer it up. Right? Obviously, there is a limit.
Sure.
Right. But that's the technology that we use, and then to buffer it up. So we don't lose data. I understand it's very important. You don't want to lose any data. And all the data is time-stamped. So as the pipe is cleared up, the data all of a sudden all come in, but with the right timestamp, so we don't lose the integrity of the timing information. Yes, sir.
The cache depth in the Flume cache depth, as you described, use Flume to buffer and provide connectivity between the different nodes in your system and to effectively cache the inspected data. Two questions. One, is it user configurable that which data, in the event of a severed connection, which data shall be retained and which data in the buffer? Or I guess ask a more clear question. Is it user configurable for the user to be able to differentiate between classes of data that will be retained in the buffer in the event of a network down emergency? And I think that actually is my question.
Yeah. So it is not end user configurable, but it is configurable. So end user call Roger, Roger will go in and then drop into Linux prompt and then do a few configuration parameter, and that will be changed.
So, and just to echo back, make sure I understood you correctly. What I interpreted you saying is that you're providing the best practices through customer engagements of which data that would be like to be retained. And my assumption is this is the standard which gets propagated out to all customers?
Yes.
Okay.
Yes.
And then for customers that have data retention policies that are independent between geographic region, in the state and local government, different countries, the laws are complex. Is there the capability in your platform to be able to say, for this site in this country, that this retention and data transfer policy will be honored?
Yes. So the way that we do that for that, because the buffering and a lot of work and configuration is on the controller. So we do support multiple controllers. So for a data center that is actually geographically spread out, we actually support the model that you have this controller is site-based. So you have multiple controllers, and each controller itself can be configured by the policy locally.
Awesome. Thank you.
Yeah, so with the controller, actually, it's also interesting. Similarly, we can support 3 vCenter and then 2 Hyper-V, but using one console. So you can look at your data center that is very much mixed in that environment. And in your vCenter, for example, this vCenter is across 3 continents, and that has yet another 3 controller. So we have that hierarchy that actually we do have customers do deploy that way as well.
Awesome.
Yeah, thank you. The architecture slide is quite important because his demo is going to base on this. I want to make sure I do my job here in explaining the architecture in terms of the tab, going into the virtualization platform to marry the information all together to provide basically what we call the full stack, right? The full stack visibility. To us, the full stack means Roger is going to demonstrate this, so I'm teeing up Roger to do this demo. So one is the end user experience. We do want to measure end user experience, right? And that we will be able to measure from the data center and knowing the remote end user remote site experience being good or bad because we're analyzing the networking packets, the round trip time, the delay time for each individual clients, right? So we're able to analyze that to determine the issue being data center internal issue, networking issue, or remote site issue, or per client issue. Plus, we build this application topology. We want to give you very deep application visibility to see how they're being put together without you having to deploy agent. And the next is when trouble really happens, when you're troubleshooting, we want to give you a root cause just with a few clicks, which Roger will demo to tell you. Then your SQL, your web server is very slow because 3 tiers down from your web server, you have a database server that is slow. And the database slow is because your IOPS is congested on this particular NetApp device. Right? So we want to demonstrate to you that is possible. And lastly is analyzing and be able to provide you the analysis and analytics of your data center, whether it's at the virtual or physical layer, give you multiple layers of visualization. All these graphs are very small. I apologize for that, but really this is just keying up Roger. Roger is going to give you a full screen view of all these visualization that we do to provide you with troubleshooting capability, planning capability, and also analytics that is so visualized.